Thank you. All right, welcome back. Thanks for hanging out with us a little while longer and answering some questions. And Chris, I think we see you here as well. So we had quite a bit of interest in the 3 presentations. And of course, this is a topic incredibly near and dear to my heart. So I hope we can have a fun discussion. The first one that I wanted to ask was to you, Eleonora, and it was several questions that came in from the audience during your presentation. Some more basic, maybe quick answers, but what type of glass did you use? Maybe why did you choose the kinds of finishes? There was questions about the dark surfaces, and then finally, of course, well, why doesn't the whole building rotate? So anyway, I think I might know the answer to the third one, but
okay.
I'll let you take it.
Okay, starting from the first. The glass, so it's a triple glaze on the facade itself, and then the column are some type of structural glass, which I know fairly little about, so it would be better suited for our structural research team. But yeah, it's they even made a bridge leading to the co-creation center out of glass, and it's working well, standing there. So it looks quite robust. And then the second one about the finishes, yeah, that's a question I had from the very first time I saw the building.
You had the same question.
Yes, I don't know. It was a collaboration with some architect studio. They liked the idea of the contrast, probably,
sure.
Which is interesting for glare. Definitely not helping, but maybe
yes.
Definitely interesting. And yeah, they went for that transparency and black surface contrast, which I have no explanation for.
Fair enough. And then the building rotation.
And the building rotation, right. It's a fairly large building. Yeah. But as part of our facilities, we have a light van as well. And I found that very smart, actually. It was already there when I joined. It's a van, which is like a test bed facility. You can replace the backside as a facade. And then in that case, you can just drive it and rotate it. So we have something to do that.
It's an incredibly exciting facility, and I'm looking forward to see what sorts of research projects that you'll be cooking up. Next up, Sneha. So the result, I think, as I understood it from your project, is that there certainly is a difference between the perceived daylight glare, or the perceived glare under the daylighting conditions with the blue glass versus the color neutral glass. And of course, you were sharing some of the results about the calculated daylight glare probability. So I was wondering if I was hearing an important difference, or maybe just a phrasing difference when I heard you say, so the color neutral glass is over predicting glare, and I thought, well, maybe the blue glass is under predicting glare. I don't know. Is there any meaning in the phrasing?
So the main conclusion is that the blue tinted people perceive glare stronger when the glass is blue tinted. And this effect is large because you can almost double the transmittance for the color neutral glazing to reach to the same strong level of glare. So you can allow more transmittance in the color neutral glazing compared to the blue tinted glazing, and still people can feel comfortable.
Yeah.
So it's but then the glare metrics, how they predict glare is so what we saw is like the glare threshold is for color neutral glazing is around 0.54%, which is much larger than what is proposed in the European standard. So one way to say this is that people can tolerate more glare when it's color neutral, which doesn't reflect what we have so far in the standard. So especially when the sun is there in the field of view.
Yeah.
So yeah, the glare metrics overestimate glare when the glazing is color neutral. So they say that there is more glare
Right.
even when there is less glare.
Right, right.
Yeah.
Yeah, interesting. I suspect that you had some personal experience, setting up the research and calibrating the study design and whatnot. I'm just curious, from your personal experience, did you have any? I guess my question is kind of around the mechanism, like, well, why might we be perceiving the blue? I think there is some research that suggests that we're more sensitive to blue light, but I just thought from a, kind of human perspective, did you notice anything different?
One thing, that I think it's a very complex question because it goes into the physiology of the eye. But one thing I did notice that people prefer natural colors more than they prefer the blue tinted glare. But this is more about their preference,
Right.
and the glare is kind of the visual discomfort they feel. So one thing could be that how the brightness perception of human eye is defined by the V lambda doesn't work same when the glazing is blue, because how it was developed was not under these kind of scenarios. So there is a need to have like maybe a different V lambda for such situation where it weight more the short wavelength light.
Yeah, I might liken it to the studies by Taucharainen that talk about the forgiveness factor associated with better quality views. In some of my own work, we did perception of indoor pleasantness and white walls versus wood walls. So there's natural forgiveness factor of the thermal comfort, actually. So I think there may be something to that we can perceive the sort of natural state, and we have some affinity for it.
Yeah, I think that's true.
Very good. All right, and Chris, I wanted to bring you in and just say, I think the work that you're setting up for creates a kind of a wide open future for the control, dynamic control of facades. And I could walk down pathways regarding visual comfort or energy optimization or acceptance and preference. And I'm curious, what are you most excited about for the next steps for Halio?
All of it, really all of it. And I think there's a lot of potential to start using artificial intelligence and computer vision to do forecasting, so you can be proactive in the control of the building to make the building more sentient, if you will, and so it's responsive ahead of time to what it sees on the horizon by using or leveraging what's currently available in AI. I think the energy monitoring in conjunction with electric lighting and daylighting can all be, create an ecosystem of control that's really excites me. And so I'm really, now that we're past this hurdle, it's nice to kind of look forward and anticipate what we'll be working on next.
That's great. So is it sort of commercially available now? Are you there?
It is. We are actually delivering them to buildings. We're trying to sell the glass first and then give them the camera, but it's sort of a nascent period. We have some installations and they seem to be doing well. We've got, I think, around 6 or 7 installations. They're kind of in beta, but they're
Right.
doing what they're supposed to be doing.
That's really encouraging. And I got to believe there's sort of happy accidents with the data that you're collecting that you thought, oh, I might be able to use it in this way or that way. Is there anything that you maybe didn't anticipate when you set out to do what you've accomplished that you're finding additional utility associated with the data set?
I think at this point, I've found more errors than I found things that inspire me. One is we had an automation routine, which I showed, but we were doing that with each capture. And at low altitudes, it's very often that you'll get reflections from the sun being so low and nearby reflective surfaces. And so we were getting a lot of jitter, and the camera was sometimes finding false reflectances and rotating the camera in completely the wrong direction. So that would throw off our sky glare calculations. But I would have to think about that. I'm sure there must be something. And it's great for birds too, if you're an ornithologist, but that's ancillary.
Fair enough. Eleonora, yes.
Yeah, if I may, it would be great to reevaluate the Paris all-weather sky model that we all use, based on more of this image and more, yeah, like a long-term collection of data from different locations. That would be
Yeah.
great.
Yeah, where are your locations? Are they mostly Bay Area so far, or are they distributed?
We've got Pennsylvania, Texas, Bay Area. We've got one in Belgium, one in Japan. That
Right.
covers the gamut.
So-
Can you use the data?
Yeah, I was going to say, my hunch is that you'll have takers. You may have a data set and a new value proposition for your
I'd very
company.
much love to see this data go to the hands of researchers or whoever can make use of it. I think it's a valuable source for, if we can capture this information for global locations, that's a wonderful data set.
Yeah, I can imagine better understanding of the spectral characteristics of the sky is such an important topic and missing. Incredibly difficult to find useful data sets in that regard. So,
especially when we have wildfires in San Francisco or the Bay Area or California, you have a different sky condition to account for altogether, which isn't, there's not a lot of data about that.
That's right. Yeah. I wanted to make the obvious connection, which is Chris, Halio, and Eleonora's lab. Like, need I say more? You should talk after the session.
Definitely.
Okay, good. It's planned. So, Sneha, I know that you and I were talking about some of what Chris was presenting in the room while he was ongoing. Is there anything that you wanted to chat with Chris about?
Yeah, I was like, one thing that I was wondering, you said like you calculate vertical illuminance, right? To quantify glare. But what happens when the source is not, when the people are not directly seeing the source, it's somewhere in the periphery, like how do you use, like what metric do you use or how you calculate that?
So what we try to do during the commissioning is get an understanding from the architects and the occupants of where the seating positions are going to be and where each occupant is going to be seated and facing. So we can run those calculations accordingly to that schedule, and we can change the calculations if seating position changes. That's really the only way we have right now of controlling for that.
Okay, yeah, it's.
Good. And Chris, I wonder if you had any questions for our two other guests in the room.
Well, if I can make a plug for Halio to Sena, our glass is color neutral, but I thought in the work that you're doing is really exciting, and it's so pertinent to the industry I'm in now with electrochromic glass, and it's nice to see that color is being taken into consideration. It's not just all neutral. I thought the building that Eleonora presented was really stunning, beautiful building, and I would love to see a sky camera in that building just because it has that sentient feel to it, where it's really responsive and proactive to its environment. And
yeah, well, I wanted to kind of pick that up and say, I asked this question yesterday of some of our guests that were presenting on dynamic control, or dynamic simulation, climate-based daylight modeling. We've seen such tremendous progress in this, and at the outset of this session, I referenced, 15 years ago, we had daylight glare probability, which was the first substantial improvement to daylight glare metrics since the Hopkinson DGIs from decades before. So the question went something like, what do you hope we're talking about, in VELUX Symposium 2015 with regards to daylight and glare and control? And I'll let each of you take a moment to answer. No particular order, so if anyone is ready and wants to go first. Speechless.
You said 2050?
Sorry. VELUX session 15 in 10 years.
Okay.
In 10 years. I'm sorry. I threw you off there. You're like, wait a second. What year is it? Yeah, my apologies.
Yeah. I guess I would say maybe we have solved it already. So we have better glare controls, and it's we understand glare better, why people perceive it, and how can we control it. So we are the questions that we are asking, we have solved.
Fleshed out the other questions that you ended on in your presentation about the role of view or eye sensitivity. or in different colored glazings. Okay, good.
Yeah.
Eleonora?
Yeah, also related to Sneha's presentation, the part where you highlight the applicability of the V lambda curve. So when it makes sense to use that and when it doesn't. And I see more and more, we all see more and more of these curves coming up, whether it is non-visual effects, whether it is visual effect, or all sorts of things. And it would be very nice to have some clarity by 2025,
Yes.
which curve to use and when, and yeah, what's the right one.
And Chris, how about, where do you hope we are in about a decade in the VELUX 15th symposium?
Well, with 2030 on the horizon, it'd be nice to be to see some post-occupancy studies, sort of vital signs of how these integrated systems are working in the building, studies that show the building and how it's responding with these systems to the local environment, what improvements are being made. Whether that's occupant well-being or energy or daylight or any number of the stimulus that affect us in buildings. It'd be nice to kind of have it all culled together into these post-occupancy specific building analysis.
That sounds good. Well, I think there's plenty of work to do to solve the problem. Many folks have been working on it for quite a long time, but I do think technology, not just HDR imaging, coming on the scene, 20 years ago or so, and really becoming more of a common available tool, and probably standardized post-occupancy evaluation, questionnaire items and things like that as well. But the ability to do something with that data has come a long way in just the last 2 decades, and I fully imagine that we'll be seeing, I think if you're going to invest in higher performing buildings, you're very likely investing in higher performing facades. And I think the notion of balancing human profile, human value for access to view, daylight, managing glare, and then also balancing that with energy priorities. I really believe that the 3 of you will likely carry a large leadership role in helping us take the next step in controlling glare in environments. So thank you. Thank you for your contributions. We're going to transition here just to wrap up today. And we have, of course, another session tomorrow, so I'll share a little bit with you about that. But first, today, we had sessions about daylight and architecture in Asia, and then we talked about pandemics and the effects of working at home and sleep regulation, and my talk on viral degradation associated with light. And then we had another section of computational design where we saw metrics being advanced once again, and I think new questions being asked, but also trying to balance the complexity, the seemingly exponentially increasing complexity, while trying to make that information useful to designers and make it useful earlier in the design process as much as possible so that we can affect the change that we're looking for in the world. And then this session on glaring controls, and I really do think that we've set the agenda for the next decade, and I'm excited to see you all achieve it. All right, so tomorrow, starting at 10 a.m., we will have a session on contact to the outdoors, followed by another installment of light and health, and then daylight and education, and then finally daylight and architecture in the Americas. So thank you so much for joining us at the VELUX Symposium, Daylight Symposium, Day 2, and we'll see you again tomorrow at 10 a.m. for Day 3.